In this video, I'm going to talk about classical test theory and its five basic assumptions. Classical test theory starts out based on five assumptions and two definitions, and we'll look at those five assumptions right now. Let's start by just looking at them at a glance, taking a glance at them. Here they are. They are x equals t plus e. The expected value of x equals t, the true score. Now I'm going to start introducing what these symbols, reminding you what these symbols stand for. Rho, that symbol that looks like a p. Rho sub et, that is the population correlation between error scores and true scores, equals 0. Number 4, the population correlation between error scores on one test and on another test equals 0. And number 5, the population correlation between error scores on one test and true scores on another equal 0. Now you can write these down now, but I'm going to talk about them one by one as well, so you also can wait and look at them one by one. Let's look at that first one, x equals t plus e. I consider this the fundamental equation of classical test theory. What it says is that the obtained score x is a sum of the true score t and the error score e. So for example, let's say that Anne gets a score of 45 on a test of creativity, which we'll call test x. And let's say that test x further has a range of scores from 20 to 80. That's not in the equation, but we'll just say that for the sake of this example. Now, Anne's obtained score is 45. That's the score she got. But let's say that her real level of creativity, her true score, is 40. That would leave her error with an error of 5, or more precisely, the test included an error of 5 points, and it registered her obtained score as 5 points too high. Now, I'll give some reasons for why those error scores can be positive or negative in a moment. But first, before we move on, let's also notice that that t and that e, they're just added together. They're not multiplied. There are no exponents there. It's a pretty simple model. They're just added together. True scores and errors are additive in this classical test score. Classical true score or classical test theory, same thing. Okay, coming back to the error for just a minute. Error can be introduced by a number of factors, and maybe I can make this clearer by using the example of a fifth grader taking a fifth grade spelling test. I think we've all been fifth graders. We've all had an experience like this at one time or another, that our scores may not quite reflect our true ability. Well, sometimes you get lucky, and our score on our spelling test is maybe higher than it should have been. This could happen if we got lucky and by happening to study exactly the spelling words that ended up on the test. That's one possibility. Or we just might make a bunch of lucky guesses. Let's see now, is crossing spelled with one S or two S's? I don't know. I'll guess two S's, and by golly, we got it right. Or just before we happened to walk into the test, two of our pals were outside the classroom and they were talking, and one was saying to the other, how do you spell clothing? I think that might be on the test. And it turns out you hadn't studied clothing, but you hear the answer C-L-O-T-H-I-N-G, and you go, oh yeah, it's like clothing, clothing. And you walk in and by golly, that was on the test and you got it right. And then there's also the possibility, another possibility is that your teacher didn't notice that you actually spelled the word wrong. Your handwriting wasn't so good and your teacher thought it was correct, but it was really wrong. So that could introduce positive error as well. So these are just some examples of how you might get a score that's higher than your actual ability. Then there are the instances where you get a score that's lower, and to some extent these are just parallel to the ones we just looked at. You might study all the items by accident that were not on the quiz. Or you might make unlucky guesses on your test. But there are some other issues as well. You might feel ill or indisposed when you're taking the test. You might not have gotten enough sleep. You might be distracted. Maybe there was a fight between your parents or a fight between you and your brother. And so for whatever reason, you just didn't perform as well on the test as you would have liked, and your actual true score, your true spelling ability, in fact, is higher. So those are some of the reasons for error. And if we think about this, how this unfolds over time, it leads us actually to the second equation, as I'll explain in a little while. But first, let's just take a look at that second equation. And that second equation states that the expected value of your obtained scores over time, usually, is equal to your true score. For example, if we go back to the case of Anne and her creativity test, if we test Anne, say, 5 times, or an infinite number of times, but if we test her 5 times, over those 5 times, her scores will tend to converge or average her true score value. This is the assumption in classical test theory that connects the hypothetical idea of the true score to the real world. I've plotted out an example of this over here where we have given Anne the creativity test, let's say 5 weeks in a row, 5 different testing periods. And on those 5 tests, she will get 5 different scores. You're familiar with this if you happen to take the SAT or ACT more than once, and you noticed, as you can hardly fail but notice, that you got 2 different scores. So Anne takes this creativity test 5 times, and sure enough, she gets a 45 the first time, a 35 the second time, a 42, and a 36. But according to classical, and that's shown in the first row there, but according to classical test theory, her true score hasn't changed. Her creativity has stayed the same. Her true value on this scale is 40 in each instance. And what's changed is that the error that the test picked up. So on the first time, it measures her 5 points too high, second one 5 too low, and so forth. And if you take those scores that deviate above and below her true score and you average them out, you're going to get something close to her true score. In the case of this example, it comes out to exactly her true score, but it'll approximate it, get nearer and nearer to it as we add testing sessions. Okay, so that's that second assumption of classical test theory. Now I'm going to deal with the last 3 as a group. They state, number 3 states that the population correlation between an error score and a true score is 0. Number 4 states that the population correlation between an error score on one test and an error score on a second test is 0. And assumption 5 is that the population correlation between error scores on one test and true scores on a second test are 0. Psychometricians introduced these 3 assumptions so as to help themselves and people who are using the theory to derive additional equations that are useful in applied settings. Now we're going to encounter those additional equations in a little while, but those are not part of this video, and I'm not going to talk about them now. But the reason I bring that up is that we can consider these 3 equations to be kind of a housekeeping equations. They're assumptions or equations to make sure that everything turns out okay. That is to say, that more derivations are possible, and with the idea that these other derivations help us understand more about tests. So that's these 3 equations, 3 through 5. They're a little bit less important, a little bit less significant, but they're reasonable. If errors are, if you take equation 4, for example, if errors are random, then it makes sense that errors on one test might not be correlated with errors on another test. Or to move back to number 3, equation 3, since errors are again random, it makes sense that across a group of people, the errors will be uncorrelated with the true scores. So to wrap up this video, those are the 5 assumptions of classical test theory. There are 2 key equations to understand, x equals t plus e, and the expected value of x equals t. there are three housekeeping equations, that the population correlations between error scores and true scores is 0, between error scores on two different tests is 0, and between error scores on one test and true scores on another is 0. And there are also two definitions that get classical test theory off the ground, get it started. And that's going to be next up. I hope you found this video helpful. If you have any comments or questions about it, please feel free to let me know. Thank you very much.